Okay, ladies and gentlemen, so yesterday we looked at functions that have square roots, and we looked at what their graph looks like. And today we're going to do a little bit more work with radicals. So you have some vocabulary right up here. So a radical expression is an expression that contains a radical such as the square root. It could contain the cubed root, the fourth root, but it's going to have some type of radical sign in it. Now, here's an important thing. A radical expression is simplified when there are no perfect squares or fractions under the radical sign or a radical in the denominator, okay? So if we end up with a radical in the denominator, which we're going to see in a minute, we're going to use something called rationalizing the denominator, which is a process used to remove the radical from the denominator. And then I'm going to come back and define conjugate in a little bit. So right now we're going to work on simplifying our radical expressions because I don't want any square roots in there. So when you have, an example here where you have the square root of 80. Now we know it's not a perfect square, but I want to be able to simplify it. So what we do is we look to see, are there any perfect squares that divide into it? Now, we're not going to use 1 as a perfect square because 1 times anything, right, that's our identity property. So what I'm going to do up here is I'm just going to list the first few perfect squares. And apparently my handwriting's not going to work today. So we have 4, 9, 16, 25, 36, 49, 64. Okay, and they keep going. But we're going to see, do any of these numbers divide into 80? And we're going to break it up into factors. Almost like when we used to do factor trees, when we, way back in 6th and 7th grade, when you would have to do prime factorization. Very similar to that. So when I look at 80, and you always want to try to find the biggest one. So I know 4 goes into 80, but I'm going to see, is there anything else that goes in? 9 doesn't, so I'm going to check 16. And 16 does go into 80 5 times. So what I'm going to do is I'm going to break this up into the square root of 16 and the square root of 5. Because 16 times 5 is 80. They each get a square root because it's the square root symbols there. Now I'm going to look and say, okay, can I then take the square root of either of these numbers? Is it a perfect square? Well, the square root of 16 is 4. I can't take the square root of 5, so we say it's multiplied 4 times the square root of 5. So this is simplified. There is no longer a perfect square underneath that radical symbol. Okay, for number 4, so here I have to actually multiply those together first to be able to simplify it because 2, nothing else goes into 2, and none of my perfect squares from up here go into 14. So I'm going to first take and I'm going to multiply 2 and 14 together to get 28. Okay, now I'm going to do the same thing. I'm going to look to see, can I break that 28 up into something that contains a perfect square? Well, I know 4 goes in. So I'm going to break this up into 4 and 7 because 4 times 7 was 28. Okay, well, I know the square root of 4. The square root of 4 is 2, so it's 2 radical 7. All right, hopefully so far so good. Apparently I'm going out of order, so let me continue going down the page here with our 54, and we'll come to the ones that have our variables in it in a minute. So 54, I lost my little list here, but I do know that 9 goes into 54, so I'm going to break this up into 9 and 6. Right, so the square root of 9 is 3, so 3 radical 6. You always want to make sure that you're double checking as well that did I really find the biggest one to use here. And if not, then you can go through and do it again. So here I have 3 times the square root of 180. So we're going to leave this 3 alone. It's just going to kind of be, it's a coefficient. It's just going to be kind of carried along for a little bit. So I have to take my 180 and I have to see what can go into that. Well, let's see. 100 does not. Does 81? No. Does 16? No. Oh, duh, how about 9? Sorry. 9 does go in. Actually, so does 36. Just doing my double check here. Yep. So I can break this up into 36, and it goes in 5 times. So now I'm going to take and do the square root of 36, which is 6. Well, this means that they're being multiplied together, so it's really going to be then 3 times 6. Well, 3 times 6 is 18, so my whole expression reduces down to 18 radical 5. All right, let's do number 5. So here I have to multiply these together. So I'm really dealing with the square root of 50, right? 50 can be broken up into the square root of 25 and the square root of 2. Now, I always write my perfect square first because I know I'm going to be taking the square root of that, but it doesn't matter because it is the commutative property. You would then, though, just write any number that's being multiplied has to be written in front of the radical symbol. So I can take the square root of 25, which is 5, and keep the radical 2. For number 6, here I'm going to take and multiply the numbers out front first, 6, the numbers under the radical sign, 48. Now I'm going to go through and do just like I did before, and I believe 16 goes into that. So I'm going to break that up into square root of 16 and the square root of 3. I can take the square root of 16, which is 4, and then I can do 6 times 4, which is 24 radical 3. If you can go from here to here, that is perfectly okay. I'm just trying to show you where all of these numbers are coming from. All right, now let's talk about when I have my variables. We know that we can take the square root of a variable if it's even. So what I'm going to do is I'm going to first start with my 90. I'm going to take that one and break it up. So I know 9 goes in. So I'm going to break this up into the square root of 9 and the square root of 10. Now I'm going to take a look at my exponents. And I can take the square root as long as it's even. So I'm going to put x squared here, y to the 4th. I should have moved this over, sorry. Right, because those have even exponents, so I can take the square root of that. It's just taking half of it. Now, z to the 5th. Well, z to the 5th has an odd exponent. But much like when I was factoring, I can divide that up into z to the 4th, which I can take the square root of, and z, which I cannot. So the z is going to stay over with the 10, because that's the part that I can't take the square root of. So square root of 9 is 3. Square root of x squared is x. Square root of y to the 4th is y squared. Square root of z to the 4th is z squared. So for the exponents, you're just taking half of it. Times 10 to the z. Radical 10 to the z. All right, so let's try the next one. So again, I'm going to take my 32. I'm going to break it up. I know 16 goes in. So I'm going to break that up into 16 and 2. Now I'm going to take care of my exponents. So r squared is even, it's going to stay there. K to the 4th is even, so it's going to go with the 16. T to the 5th I have to break up just like I did z to the 5th. So we're going to have t to the 5th, oops, we're not, we're going to have t to the 4th, sorry. And over here we're going to keep the other t. Now I can take my square root. Square root of 16 is 4. Square root of r squared is r. Square root of k to the 4th is k squared. Square root of t to the 4th is t squared. And then we keep 2 radical t. Okay, 56 can be divided, let's see, 9 goes in, no. 56 divided by 4. So that one will work. So I'm going to break this up into 4. And that goes in 14 times. Now, x, I can't even divide that up because it has an exponent of 1, so it's going to go with the 14. Y to the 10th is going to go with the 4. And z to the 5th, just like z to the 5th up in number 7, we're going to break that up into z to the 4th and z. So square root of 4 is 2. Square root of y to the 10th is y to the 5th. Square root of z to the 4th is z squared. And then we keep radical 14xz. Okay, hopefully you guys are kind of going along here. The more you do these, just like with everything we've been working on this year, the better you're going to get at it. So let's see. So now I want to go through and we're going to do this thing called rationalizing the denominator. Yeah, okay, sorry. So if I have, so here I have a fraction, so this is a multiple choice question. So I can't keep a radical sign in the fraction. So what I'm going to do is I'm going to first take this and break it up into the square root of 35 and the square root of 15. And then I'm going to look to see, well, is there anything that I can take and divide those out by? And there is not. So to rationalize your denominator, you're going to take whatever this square root was, and you're going to multiply the whole fraction by that over itself. Because anything over itself is 1, and the identity property tells me that I can multiply by 1, and I'm not changing anything. So by multiplying this, I'm not changing the value of the problem. So now when I do this, right, just like I did before, I'm going to multiply the numbers underneath. So 35 times 15, this is going to be the square root of 525. The bottom is going to be the square root of 225. And now I'm going to look to see, just like I did before, what else can I do with that? Well, 225 is a perfect square. So that would be 15 in my denominator. So now I don't have a radical sign in the denominator. It's okay to have it in the numerator, but you cannot have it in the denominator. I'm going to check to see, is 525 a perfect square? And it is not. So now I'm going to see, is there anything that can go into that? And my guess is 25 goes in. Yes, 21 times. So just like I did before, I'm going to break this up into 25 and 21. And I can take the square root of 25. I'm going to continue over here because I wrote too big. Square root of 25 is 5. We keep the square root of 21 all over 15. Which up here is given as choice A. These could then be reduced to 1/3 square root of 21, but they didn't do that here. Okay, so for this one, we have to simplify 6y over the square root of 12. So I'm going to multiply by the square root of 12 over the square root of 12. 6 times 12 is now the square root of 72, and we keep the y. 12 times 12 is 144. So now I'm going to see, can I go through and simplify these? This is a 72, by the way. Well, I know that 9 goes into 72, so I'm going to break this up into the square root of 9 and the square root of 8. But the y, because I don't have an exponent that I can pull out, the y is going to stay with the 8. And the square root of 144, I already know, is 12. So up here, square root of 9 is 3. And we keep the 8y. Oh my gosh. That's underneath the radical sign. And then the 12, and this one they did then choose to reduce because 3 goes into 12 4 times. So radical 8y over 4, which, guess what? I screwed up. I didn't screw up. I just missed one. Because 8 can now also be simplified down a little bit more into the square root of 4 and the square root of 2y. So the square root of 4 is 2. So see, sometimes this happens. Over 4, this then cancels again. So radical 2y over 2, which was h. We're going to work on the whole conjugate thing. We're going to work on that together. So for right now, I think we're okay. I know it was a little bit long, but any questions, as always, bring them to class.